Hello to you all grade 12s. Having introduced you to the momentum, the changed momentum, today I want us to look at the conservation of linear momentum. The very first thing that I want us to do is to state the principle of the conservation of momentum, which is 2 marks in which is required for you to be able to state in words, which is 2 marks in a physics paper 1 around the equation 4 is there. Okay, yes. So basically we are going to first discuss your 2 marks. Okay, it's very important, guys. And also it's very important for you to understand, so that you can understand the systems that you're going to be calculating, accelerated systems, and an end in relation to conservation of linear momentum. Okay, so just before I state, let me first underline the word conserve, because we're going to talk about more about the word conserve as we move forward under the conservation of linear momentum. Also, when we talk about the conservation of kinetic energy, right? Yes. So, however, when you talk about conservation or something that is being conserved, mean that it doesn't change. Okay, it doesn't change. Mean that it stays constant. Okay, yes. So when it states now the principle of conservation of linear momentum, it states that the total linear momentum in an isolated system remains constant if the impulse of the external forces is 0. So when it states the principle of the conservation of linear momentum, it states that it states that the total linear momentum in an isolated system remains the same, or remains constant, if the impulse of external forces is 0. External forces is 0. That's how it goes. So, the principle of conservation of the momentum states that the total linear momentum in an isolated system remains constant or remains the same if the impulse of external forces is 0. And that's how it goes, guys. Okay, yes. So those are basically your marks, which is going to be around your 2 marks and okay, yes. So that's how it goes. So let me make an example of this. So it is expressed in this form. Okay, yes. So the sum of initial momentum, or the initial momentum, or the momentum before, is equal to the sum of the momentum after, or the final momentum. So meaning that now, when we are doing the calculations through these instances of 2 objects or several objects that are colliding, so means that we're going to add the sum of initial momentum of the both objects and the sum of the final momentum of the both objects, meaning that it's going to be the same. Okay, yes. When you circulate this side, it's the same as this side, but we're going to prove that through calculations. Okay, yes. So meaning that now, if for example we have 2 objects, we have object A and object B, okay? And object B, okay? Yes. We have 2 trolleys there. Object A and object B are about to collide. Meaning that this is initial, okay? Yes. So let's say object A is moving towards object B, okay? Yes, they are moving towards each other, and this one moves to the side, okay? Yes. Which is going to be equal to after they have collided. Okay, so this is going to be object A collided with object Okay? Yes. So mean that after mean that we can specify all the statements or the scenarios are going to specify the direction after they're collided with each other. However, my point on this was to show you that the other point was to show you that if you can see initially, I mean that there's two objects were separated, but after momentum after the objects are in contact, mean that are together, they are oneness. So mean that in this case, man, we are going to have, when calculating the momentum, the sum of the initial momentum, we're going to have the mass of object A multiplied by its initial velocity plus the mass of object B multiplied by its initial velocity, which is going to be equal to, look now, indeed we can express in this form, but we are mathematicians, we're all mathematicians, right here. We have to make things very, very easy. So the mass of A is in contact with mass of B. We are going to add both masses to make things very easy and clear. Okay? Yes. Mean that if there are one object, either they are moving west or east, they are going to have the very same velocity, which is your final velocity, and that's how it goes. I hope you get that. Let me make an example whereby now, before there were one object, but now they are separate objects. An example of this could be, first of all, an example of this could be two cars colliding each other, a car and a truck, or two minibuses, whatever the case may be, two cars colliding each other, and after the collision, they are together. I think in most cases, we also experience those kind of collisions, right? Whereby they are together, and that's going to be the instance. All right. So let's say now, object A is in contact with object B. So mean that they are in contact, okay, with object B. And this is an example of a car. So sorry, this is object B. Sorry about that. This is an example of a car pulling a trailer, or pulling a trailer or a cart. Okay. All right. So this is object A and this is object B before the collision. Okay? Yes. Before the collision, and this is object A and B separately after the collision. Okay? Yes. So meaning that now after the collision, you know that the sum of initial momentum will be equal to the sum of the final momentum after. So initially, yes, they were together. Okay, so look, initially they were together, they were one object. So the masses were together with the very same initial velocity. So mean that we're going to have the mass of A plus the mass of B multiplied by very same velocity. They have the very same velocity because they're one thing. Okay, that's one system. So now, after the collision, the trailer moved away from the car. In most cases, that happens whereby a car that was pulling a trailer is involved in a car accident or is involved in a collision. So meaning that the trailer, in most instances, you might find out that it has been banged away, or that he has lost the touch from the car. So mean that you are going to have the mass of the trailer of A, okay, yes, multiplied by its final velocity of A plus the mass of the car, which is B, multiplied by its final velocity. Okay, so sorry, final velocity, okay, of B. All right. So if you can look the graph on this, you can clearly see that before, yes, they were one. They consisted of one or of the same velocity because they were one object. But now they're not the same. They're separate objects. That's why I've separated them now. Okay? Yes. Because A trailer is going to have its final velocity, and the car is going to have its final velocity, which is object B in that scenario. And lastly, if ever, let's say for example, we have two objects that are separate. Okay, yes, two objects that are separate. Okay, we have object A and we have object B. If we have object A and object B, okay, just say like that, and this is the initial momentum, the sum of initial momentum, and after, in the end, they are still separate objects. Okay, yes. If they are separate objects, you can clearly see that. Okay, so this is our A, and this is our B. Okay. If they are separate objects, so meaning that initially, the initial momentum, this is the sum of the initial momentum, which is equal to the sum of the momentum after. So meaning that this is going to be ma of its initial velocity and the mass of b multiplied by its initial velocity, which is going to be equal to the mass of a multiplied by its final velocity and the mass of b multiplied by its final velocity. And this is going to be your formula to substitute your variables, or to substitute the magnitudes that are being given there, as well as our vectors. Okay, yes, which is the velocity, the mass, okay, yes, and yeah, so that you can move forward. So this is the way of putting your formulas first. Okay, yes, you can apply your formulas if the objects before, whether we're in contact or we're separated after we're in contact, whatever the case may be. I hope you understand, right? Yes. You can pause and just look the graph at that, and that's how it goes. So guys, next time we're going to be dealing more and more of calculations and the following videos. Have a great day. Cheers.